In this session, I'll be talking about benefiting from design of experiments. At the end of this session, you'll be able to describe the layout and benefits of DOE. Where are we at in the overall roadmap? We're in the approve phase, and what we're looking at, the various deliverables that we have listed on the left-hand side, some of the tools that we're going to be talking about, but in particular, I'll be talking about design of experiments for this session. Where is it at in the overall roadmap, the project execution guide roadmap? This is where we'll be talking about in design of experiments. And I'll be talking about basically the advantages of DOE for this particular session. Again, we start with a 30,000 foot level report out that we're trying to improve through design of experiments or whatever we can. But in this section, we're going to determine what factors really could make a difference on the output of the 30,000 foot level metric. We're going to be conducting hypothesis tests, basically using design of experiments from factors that we thought were important in wisdom of the organization. We then want to look at statistical quantification of how much these factors or changes we made to the overall 30,000 foot level view. The difference of what we got right now is we're going to be working at trying to change the process and basically kick it instead of just analyzing it passively. So functionally, basically what we have is got the 30,000 foot level chart, and then we want to look at improving it because we got some non-conformance rate. So we'll pull for project creation, and then after we learn some things through DOE, we can change the inputs, and now we've got bottom line benefits. So that's how design of experiments can fit within a big picture in Lean Six Sigma projects. So analysis of various regression techniques are useful. We can analyze variances. Through analysis of variance, could assess difference between departments, supplier, machines. In regression, we can look at temperature, pressure, and so on. But these are look within the certain boundaries of what's happening right now, and I call that passive analysis. So the advantage of analysis of variance regression techniques is we can actually look at the actual data without making any changes to the overall process. The disadvantage, regression may not show temperature is significant, but if we really had temperature, for example, at a farther extreme than it currently is operating at, it could real positively affect our overall response. So we want to basically look at the impact of these other factors beyond what's normal operating at. George Bach said that you find what happens to a system when you interfere with it, you have to interfere with it, not just passively observe it. So that's basically leading to design of experiments where we're kicking the process to gain insight to what we can do to improve it. What we're looking at here is an overall approach which many factors within a process can be changed at once and data can be observed collectively, improvements in degradation. So 2K DOE analysis, where 2 represents the number of levels that we're going to have for a particular factor, and K represents the number of factors we're going to look at within one design of experiment. So with this, we can look at the significance of the factors level, and we can also create a prediction model for the response. 2K approaches can have a full factorial, that's all possible combinations, or a fractional factorial, where it's a subset of all combinations. So I'm going to really be focusing on the fractional factorial because that's where you can gain the most benefit for the least amount of work. So DOE techniques are an efficient strategy that has a wide range of applications. In other articles, it's referred to as multiple variable testing. So in this module, we learned about layouts and benefits of a DOE.